Quite a few questions on 16.14, the pH of a buffer that's prepared by mixing 30 milliliters of 1 molar HF and 20 milliliters of 2.5 molar potassium fluoride. HF is a weak acid, and the KF is its conjugate base. So what we want to do is we're mixing both of those solutions together to make the buffer, so we need to use first M1V1 equals M2V2, because I'm taking a 30 milliliter solution and I'm diluting it to 50 milliliters when I mix those two together. So my initial concentration, I've got a 1 molar solution of HF at 30 milliliters, and I want to find my new concentration once I dilute that to 50 milliliters. Do the same calculation for potassium fluoride, except for I've got a 2.5 molar solution. I only take 20 milliliters of that. My new concentration of potassium fluoride once that's diluted to 50 milliliters. So now I can find my new concentration of both of those. So my HF is 0.6 molar and my potassium fluoride is 1 molar. Now we can use the Henderson-Hasselbalch equation to find the new pH of this solution. Henderson-Hasselbalch pH equals the pKa plus the log of the concentration of my base over the concentration of my acid. Remembering that pKa is the negative log of Ka. So the pH of this solution would be the negative log of 7.2 times 10 to the minus 4 plus the log of 1, because the potassium fluoride is the conjugate base of HF. So 0.1 divided by 0.6. So take the negative log of 7.2 times 10 to the minus 4 plus the log of 1 divided by 0.6, and I get a pH of that solution of approximately 3.4. Probably the first step that probably people struggled with was M1V1 equals M2V2, kind of material from last semester, but it's still important to understand that we are changing concentration. And we need to find the new concentrations once I mix those two solutions together, right? Because this is more of like what you'd experience in a lab setting if you had to go make a buffer. Okay, I have a solution of X concentration of my acid, X concentration of my conjugate base. What volume of each of those do I have to mix together to give me this amount of buffer with this pH range? So that was the first step of using M1V1 equals M2V2 to find, after I mix those two solutions together, my new concentrations, and then once I had that, then you can find the pH of those solutions.